I guess we can slowly start. So, good afternoon. Welcome to the first afternoon session. I'm going to talk in this and in the next session about temporal data. So, temporal data in relational database in SQL Server, which is a topic that, although frequently people have problem with this kind of data, it's not really well covered, and definitely we are lacking support for this kind of data out of the database. My name is Dejan Sarka. I think we all met already, so I will not spend a lot of time here. So in this first part I'm going to define things. So what exactly is a temporal database? And focus on constraints. So what kind of constraints can you have? I'm not saying that you must have all of them, depends on your business program. But what kind of constraints do pertain to temporal databases? And then I will show possible solutions and kind of simplify the problem by introducing a new interval data type, and then we will still have some problems left, so some constraints to develop. So I will also develop 2 new operators, pack and unpack, and briefly discuss the proposed 6 normal form. And in the second part, the last talk, in this today, I'm going to, of course, talk about optimization of temporal queries, which is also very specific and, as you will see, pretty much completely new. So, theoretical background. James Allen already defined what kind of operations should interval data type support in early 80s. So this is the point when the theory started to evolve. And Chris Date and Hugh Darwin and Nikos Lorenzos wrote this book, Temporal Data and Relational Databases, at the end of previous millennium. It was published in the beginning of this millennium. So this is kind of strong theoretical background for the complete temporal data support, not just the data type. Also, you see, problems with optimization evolved immediately. As soon as you introduce temporal data, you have some problems. However, until 2000, there was really no theory behind how to solve these problems. So in 2000, Kriegel, Petke, and Siegel from Munich University published this white paper, Proceedings from Conference, where they proposed relational interval trees, a model that can help optimizing these queries. However, it turns out that this was purely theoretical solution, because yes, if you got these relational interval trees, then you can speed up queries. However, building these trees was too expensive. And in 2011 and 2012, Laurent Marquand from France invented mathematics needed to build relational interval trees with simple calculations in linear time. So this suddenly became kind of possible. Now let's go to practical solutions. So I first implemented full solution for temporal problems, including constraints, the part that this talk is based on in this book, Inside SQL Server 2008, Transact SQL Programming. And I'm co-author, my author is Itzik Bengal. And last year he published Interval Queries in SQL Server article where he introduced Transact SQL solution for relational interval trees. There is a slight deviation Davide Valori, guy from Italy, also last year published possibility to use spatial data. And I added last year 3 additional solutions for optimization of temporal queries. And in the end of the next talk, I will also introduce the 4th one, which I am currently working on. So you will see that after all of these years, we have enough solutions. Together we have 6 different solutions, 5 of them supported with the code. The last one I will talk theoretically, it's only an idea. And so far, let's say not just idea, it's already the algorithm. Just somebody needs to sit down by the computer and start programming. And so we have different ways how to optimize, and we can implement all kinds of constraints. And yes, I still think that it would be at least partially duty of Microsoft to put more support in the product, and also other systems like Oracle and DB2 should put more effort. But at least, let's say, it is finally, let's say, doable to get a reasonable solution that supports everything you need from constraints and also gives you the performance you need. So, what are actually temporal databases? You see, in a relational database, in a relation or in a table, every row or tuple actually represents one proposition. So if you look at row of the customer's table, you see the proposition customer with this name lives on that address and I don't know, if his company has so many employees, etc. So this is proposition or true fact. Now, these kind of propositions are simple, are not time-stamped. So we pretend that these kind of propositions are true forever. So they have been true forever, and they will be true forever, and they are true in this moment. Temporal databases hold time-stamped propositions. So propositions that are valid, true, only in a specific period of time, in validity time. And these intervals can be open-ended or closed. So we can have open-ended or semi-temporal propositions, like this proposition is true from or since some point in time. Of course, we could have open on the other side as well, so we would pretend that some proposition was true forever, but is true only until some point in time. Anyway, to solve the problems, we need to focus only on one side. So I will deal only with since propositions, not until or up to some point in time. And then we have propositions that are valid in a closed interval of time. So from to, or with a single word, they are valid during some interval of time. And we have many business problems with such temporal constraints. For example, you have partners, suppliers, which have contracts that are valid only during some specific period, or you can also have open-ended contracts that are valid since that time. And you have all kind of food that has some validity time, etc. So there are many temporal problems, as I said, not really strong support from the relational database management systems. Now, before we start discussing possible constraints, we need to introduce some background. So first, how do we work with time? We know that time is continuous. However, we work with time as if it would consist of specific time points. And depends on our business needs, we define the granularity of these time points. So for example, a contract might be valid from a date to a date, so we simply pretend that the lowest level of granularity is day. For some other purposes, we might go to the second granularity, or month or year. But we pretend that time consists of these time quanta or simple time points. And actually each time point is basically an interval, because time is continuous. However, to simplify work with time, this is how we do in real life. And you know that application is just a subset of system in real life, so it must somehow mimic real life behavior. So semi-temporal problem. I will work on this example that was introduced by Chris Date in his theoretical work. So we have suppliers, or let's say suppliers contracts, and we have suppliers products. Of course, suppliers products is intermediate table in many-to-many relationship. Actually, there is also table products somewhere here hidden. But in order to simplify the explanation, I will focus only on these two tables. So these two tables have times-time propositions, however closed only on one side, so we have a semi-temporal problem. So we have supplier ID, which is the key of these suppliers, and we have supplier part or supplier product, which is the key of this supplier's products table. Now, basically, semi-temporal problems are not very complex. So what we have here is regular primary keys, like without this additional column. So here is supplier ID key, and here the primary key is supplier ID part ID. Also foreign key from this table to suppliers is regular. And of course, yes, there is also some, let's say, invisible foreign key to products. Right? However, immediately we need an additional constraint. There should be no supply from a supplier that is not under a contract. What does it mean? It simply means that these scenes for supplier 1, values in these columns, must be greater or equal than value in this column for supplier 1. So this is an additional constraint that must be immediately implemented. And of course, you can imagine that this kind of constraint cannot be implemented through a foreign key, so we'll have to work with triggers. And since this problem is pretty simple, I will go and show the first demo immediately. Just implement it. And I will create an auxiliary table, and I will explain this table in a minute. Just this is not important at the moment for semi-temporal problem. Actually, what I'm going to do is I'm going to use integers instead of dates in this since problem. And this will be a lookup table. And I will explain in a moment the theory behind it. But this is not important for semi-temporal constraints. So what I've got here is regular suppliers table, just I renamed it to supplier scenes, which has supplier ID, company name, okay, other columns, which I don't show for the sake of simplicity, and scenes, which is in this case integer. And as I said, I will explain the theory behind in a minute. And similarly, suppliers product scenes, we have supplier ID, product ID scenes. Of course, we should have quantity, etc., but this is not important for this explanation, so let's keep it simple. And we have foreign keys, and this foreign key to these date numbers I will explain also in a minute. Other foreign keys are regular. So we have foreign key to from suppliers products to suppliers, and from suppliers products to products. Now what is about this foreign key to this auxiliary variable date numbers? Well, this is an additional constraint. I'm not explaining why I decided for integers yet, just explaining these foreign keys. This is an additional constraint that guarantees that none of these scenes falls out of possible dates. So for example, what could be the lowest date? Well, probably the date when I established my company. Okay? So I couldn't have contract before. So this is just at the moment additional constraint, so we have only valid time points. We don't even say that these were days yet. Okay? Now, what else do we need? Of course, we need these additional triggers. So I need an additional trigger on the supplier's products table, which should check inserts and updates, fire after insert and update, and check whether we have a row in the supplier's table, supplier scenes, where this scenes is lower or equal to the scenes I am inserting or updating. If such row doesn't exist, okay, or if I find for the same supplier, of course, if I find scenes that I'm inserting in products, suppliers' products, lower than scenes for the same supplier and suppliers, I will simply reject this update. Now, this is not enough. This is not enough. We need trigger also on the supplier's side. However, this trigger on the supplier's side needs to check only updates. You see, let's say deletes of supplier that should have some product supplied will be prevented by a foreign key. Now I must also prevent update of the scenes value in the supplier's table. Somebody could update it to some higher value, so suddenly the scenes would be higher than the lowest scenes in supplier's product. So similarly, I have to prevent this kind of updates. So for the same supplier, I must check that when I'm updating these scenes, that there doesn't exist any scenes in supplier's products that would be lower than these scenes. And if it does exist, simply reject this. Now let's insert some demo data. Okay, couple of suppliers. And okay, these are a couple of suppliers. So this supplier is my supplier since time point 10, this one since time point 15, and the third one since time point 17. And couple of supplies. So supplier ID, product ID since, so supplier 1, product 20, time point 10. Valid, 10 is greater or equal than 10, and so on. So this is valid. Fine. Let's check the data. Everything is valid so far. Now let's try to insert some invalid data. So this is since too early. You see, this is why I have this datenums table. So I'm trying to insert time point that is not valid in general, overall, or by company. Okay? And let's try to supply. Remember, supplier 1 was my supplier from time point 10. Now I want to insert a product for this supplier in time point 9. And of course, this is rejected in the trigger. Now from the other side, I'm trying to update this supplier table for supplier 3. So I'm updating scenes to value 24. Let's see again the content of this table. So supplier 3 was my supplier since time point 23. In time point 23 already supplied me some product. So if I update the suppliers table, update this to 24, then this product was supplied before the supplier was under a contract. So this was rejected by the update trigger on the supplier's table. Querying, well, because I used integers instead of dates, for querying it means I need additional join to get the actual context of my integers. And otherwise everything is similar to queries with no temporal propositions. Okay? So this part was pretty easy. And of course you can imagine that the second part is much more complex. Okay? So first, what is full temporal, and let's see what kind of problems do we have, and then we'll start developing solutions. So now we have from to. So we have from date and to date. So supplier 1 was under contract in these time points from 4 to 10. But look at supplier 2. Supplier 2 was under contract in time points 2 to 4 and also in time points 7 to 10. Now immediately supplier ID cannot be primary key anymore. Supplier ID is repeating. Similarly here, supplier 2 supplied product 2 in time points D5 to D9 and also D9 to D10. And I guess this is this correct? I think this should be supplier 1 because supplier 2 was not. Yes. Definitely. Now it looks better to me. Now it looks better. This is the advantage if you are the author of the So this should be supplier 1. Supplier 2 was not under the contract in time point 5. So this would be invalid data. So let's now describe the constraints. So first of all, we have a problem with primary key. Also here, supplier part cannot be a primary key anymore. So what is a candidate key for this table? Well, we have two options, supplier ID and from, or supplier ID and to. And here also we have two candidates, supplier parts from, supplier part to. So in both cases, we have two candidate composite keys which overlap. Is this a problem? You know, from normalization theory? This is actually violating the Boy's code normal form. So this means I will not even go into this normal form, but it simply means a problem. There is some kind of redundancy, so at some point I will have problems with data consistency. So this is first part. Then also, because this is not unique, how do I create foreign key? Cannot create a simple foreign key anymore. And then there are additional constraints that pertain to these temporal propositions. So for example, and this is the part when I said I don't mean that you need to implement all of these constraints, but these are possible constraints in this temporal data. So one possible constraint would be that I don't want to have the same supplier under a contract that finishes at one time point and next contract starts immediately in the next time point. This should be one contract, let's say. Also, I don't want to have overlapping contracts. I want to have a supplier under a single contract in a single time point. Okay, contracts can be open-ended. This is simple. Go to semi-temporal problem. This was the problem. Okay, additionally, to should not be less than from. This is not a big deal. We said no overlapping, no abuting. These are these additional constraints you might want to implement or not. And definitely you want to implement this one. No supplies if supplier is not under a contract. And here we have a problem. There is no way how you could create this constraint with foreign key and with a simple trigger like we did with the scenes problem. Every query immediately becomes very complex. Not to talk too much, but just think of it. What does it mean? This interval, for example, for supplier 1, should be included in at least one interval here for supplier 1. In at least one. Okay? So this is not so easy. And this interval should be included in either this one for supplier 2 or this one. So these are immediately pretty complex queries. And no simple foreign keys. Yes, if we would have some kind of extended temporal foreign keys that would have possibility to define this inclusion dependency, this would be nice. But we don't have them. Now let me go a little bit in theory. So Snodgrass, Richard Snodgrass proposed that we should define interval as a length of time. So just length, and then period as anchor duration, begin end. Chris Date suggested differently. I will go to this first bullet in a minute. That interval is a closed duration, but he said between begin and end of time. Okay? Now, closed duration, this is the same as anchor duration. So Date's interval is kind of very similar to Snodgrass's period. And Date already also noticed that we don't need this fixed length because this can always be calculated by subtracting begin from end. So why would we complicate? And also Date suggested that we should call this interval, not period, because period is more directly connected with time. Interval is more general, because why would we be limited to intervals of time only? For example, we could have intervals of temperature and so on. And Date suggested that we use interval. So I decided to use Date's theory because it's really more complete. And however, this is the point where I didn't really get why would I need begin and end of time. And how do I define begin and end of time? So, you see, with the lookup table, begin and end of time can also be moved. Just insert additional rows and you are, or delete some rows or update, and you are moving your begin and end of time. So, you know, like this lookup table kind of serves like this Mayan calendar. So, 2012 December, it was end of time. And in my table, I think I filled up to 2030. So maybe, you know, after I'm retired, somebody will research this and discover that in 2030 there will be an end of time, end of the world and end of time. Anyway, you know, I think I will be well retired by that time, so I simply don't care if somebody needs more, you know, just insert more rows, and that's it, or update what they mean. So, you see, this is the most important point, why a theoretical point, why I could use this kind of solution with the lookup table. Remember that we are working with time as if it would consist of these small discrete time quanta, discrete time points. So, how many these time points do we have? Actually, if you think of it, we can count them on any interval, but altogether they are countless, if we accept that there is no end of time. Let's suppose that there is no end of time. So they are countless. So what I'm trying to say that we have a countably infinite set. And you see, basically, if we go to the roots of the relational model, relation represents a specific kind of a set. A set of, let's say, similar entities, and we define these similarity entities that have the same attributes. So in set theory, a set can be anything you define, like I could define here we have a set of people in chess. However, this should be two relations in a relational model. Now, at some point, Bob needed to decide how we represent sets. And he decided for tables, which is the most natural representation. Tables were initially used for any kind of data storage. Anyway, as soon as you decide for a table, then you get additional limitation by representation. In a table, we can represent only countably infinite sets. You see? We can always count rows from some point to some point, but imagine that you have all on disk space you need. It simply means that the length of the table is unlimited. Actually, this is not the limitation of the relational model itself. The relational model is not limited to countably infinite sets only. However, this is what we can represent with tables. Now you see that it theoretically fits very well together. We have time points, we have countably infinite set of time points, and this can be represented with a table, actually with a lookup table. And so suddenly our interval is not only time interval, depends on the other column in the lookup table. This is where you give the context to that integer. Of course, sets of integers is countably infinite discrete set. You see? So any countably infinite discrete set can be transformed to integers with a functional transformation. So once you work with discrete sets, turns out that it doesn't matter whether you work with open or closed intervals, open in terms whether the boundary is part of the interval or not. So with discrete sets like integers, for example, open interval from 2 to 6, open on both sides, is the same as closed from 3 to 5. Okay. So actually this is an arbitrary decision, and somehow I was this checking based on, this is cable connection, I don't want to step on it because it will be useless later. Okay. So this was arbitrary decision. I was thinking how to program this, and it seemed to me somehow easier if I decide for closed intervals. Okay. So I simply decided for closed intervals, and to make clear distinction from Snodgrass's interval, named it interval SID, so interval on countably infinite discrete sets. Okay. Now, Snodgrass also suggested that we should actually have bitemporal databases. So we should have validity time and transaction time. It looks like to me that this is completely unnecessary. Also, Chris Drake says this is completely unnecessary. Transaction time is something that database needs to know, not people. We are working with validity times, and we have transaction time in transaction log. Okay, it's not open by SQL Server, but if we need it, it's kind of there. And you can even get it, let's say maybe with change data capture or so on, but at any point Microsoft could decide and create some dynamic management view which would retrieve this information. It would be useful also, you know, if you need to restore to point in time to see the actual transaction time. Could be useful at some point. Oracle has this, Open has a kind of view on this transaction log, so you can see the transaction times.
So just in the by temporality, do you never think about a need to go back and change what you thought was valid at the time? So say I've got something that was valid for last week, and last week I believed it to be valid for that time period, but then say something was miskeyed into the database, then you have to go back and change what was valid for that time period.
Yes, but you are still, I mean, you are talking about changing the validity time, not the transaction time.
But I would still like to know what I thought it was last week.
You would like to know why?
What I thought it was last week.
Okay, this means you would like to keep versioning.
Yes.
Yes. And this was actually, this is a completely valid question. And we'll discuss this with 6 normal forum, which should cover also this all versions, so all validities at some point in time. Thank you. It's a very valid question. However, transaction time is fixed, immutable, so it is written automatically. A little bit more theory. You see, in order to get this interval type, I need to define it on point types. And this point type must support total ordering. Otherwise, I cannot know if 2 is greater or equal to from, if 2 intervals are overlapping, and so on. Of course, now when we represent this with integers, yes, this is already solved. But worth mentioning that it's not given that any data type supports total ordering. So in this case it looks yes unnecessary slide, but it's worth mentioning that with different decisions this might be also an issue that would need it to be solved. Okay? So we'll define intervals as time between begin and end points, and of course we have to include that begin is lower or equal to end. Now this interval data type, as I said, James Allen already defined in 1983 what kind of operations would be useful for intervals. So, many Boolean operators, checking whether two intervals are equal, checking whether one interval includes another, and whether one is included in another, the opposite definition. Now, includes means that it could also be the same interval. Each interval then includes itself. Okay? Then we can also define proper inclusion, like yes, interval 1 is properly included in, or interval 1 properly includes interval 2 if they are different. So at least begin or end must be different. Okay? Properly included the opposite direction. We can define before. One interval is before another if it stops before another starts. And of course we can define the opposite operator after. Meets operator, two intervals meets if one ends just the time point before the other starts, or the opposite if the other ends just in time point before the first one starts. And this is interesting, two interval overlap. If begin of one interval is before end of the other one, but also begin of the other one must be before end of the first one. I will show you, maybe I can draw this. So when do two intervals overlap? I got couple of intervals here, okay? So, this, first, they can all overlap. Let's say this is first interval, and these are all others to test. So, this one can overlap only if this begin starts before end of these intervals. So, let me draw this interval here. So, this end is before begin of the first one, so there is no chance that they would overlap. Now this is not enough, because this begin starts definitely before this end, so it is not enough. So I must have additional condition, and additional condition says that this is logical end. Begin of the second must be before end of the first one. So you see, begin of this one is after this end. And begin of this one is before this end, while begin of this one is before this end, so they do overlap. So these are necessary and sufficient conditions that two intervals overlap. Please note that this is interesting. This can be also expressed differently. This can be also expressed like begin 1. I will just use keyword between. Between begin 2 and end 2, or begin 2 between begin 1 and end 1. This is equivalent, logically equivalent condition. So it simply means that at least one begin either this one or this one must be in another interval. So in this case, this begin is in this interval. Let's say in this case, this begin is in this interval. So they do overlap. In this case, this begin is not part of this interval, and this begin is not part of this interval, so they cannot overlap. So this is logically equivalent. Now I spent a lot of time with overlaps operator, because it turns out that this is the operator. You know that in a relational model we have these relational algebra operators, joins, filters, and so on. And it turns out that we can express all operators with 5 basic operators. Okay? So, which 5? Does anybody know? I would say that the answer is correct. There are not defined which 5, as long as cross join is part of them. Cross join is the operator of all operators. And then you can take any 4 and you can express all others with this 5. Sounds like my wife, I was frightened for a moment. So, similarly with interval algebra, with interval operators, overlaps is one that can be expressed with no less than 13 odds. So what does it mean? It simply means it is the most complex operator from the Boolean operators. And this is important for the second part, for the optimization. It simply means if you solve problem for overlapping intervals, you have solved all of the problems. That's simply. You can even see from definitions that it's easy to understand what does it mean that one interval begins another. Overlapping is the most advanced concept. Okay, one interval begins another if they have the same begin, but the first one ends before the second one ends. Ends is the opposite. Now merges is a Boolean operator that simply tells us whether I can merge 2 intervals in a single one. And this is possible when they either meet or overlap. Then it's possible to merge them. Otherwise, merge makes no sense. So for example, this and this interval, I cannot merge them and get a single interval. Now then we have interval algebra operators, which simply means they accept intervals as an input and return a single interval. So we can define interval union, which takes the minimum begin and maximum end, but only if these 2 intervals are mergeable, you see. Then we can do this union. Intersect is even more strict. It's not enough that they are neighboring. Intersect is defined only and only if they overlap. And then we take the bigger begin and lower end. Minus is also kind of complex. So with minus we have even one more problem. So when does minus make sense? Well, it might make sense if 2 intervals have nothing in common, so first minus second is the full first. However, we have a problem if one interval is included in another, but without borders. So this situation, this interval and this interval. So what does it mean, this interval minus this interval? I will get 2 possibilities, see? So this is not correct result, you know, like with set operators or relational operators. You cannot get from except operation 2 tables. So also here, so we simply forbid minus in this case, because we don't know what would be a correct result. Now let's revise these full temporal problems. Now first, you see, we have now this interval SID data type, which I will show in a minute. And once we have it, then we can design our database differently. So instead of having 2 columns from and to, I can have a single column during, which is of interval data type, which implements all of these operators. Now, in this case, everything becomes much clearer. So first of all, I don't have 2 candidate keys anymore. There is just a single candidate key, supplier during and supplier part during. Now, I need just a short discussion here before I move forward. You might think now I have a problem with normalization or what. I have just hidden the problem by introducing complex data type. No, it doesn't work like this. You see, this is fully normalized. It doesn't break first normal form because during values are scalar. Now we must define what is a scalar value. Turns out that the definition says it depends. You know, a value is scalar depending on how you use it. If you modify or whatever you do with your value only with methods, operations defined on the data type, then you treat it as a scalar. If you go beyond these methods, then you treat the value as multi-valued whatever. And you see, this is exactly the same how we work with things in real life. You know, if you take a car, my car for me is pretty much scalar value. I operate with it only with methods that are defined on the data type car, steering, whatever, you know, braking and so on. However, for my mechanic, the same car is not a scalar value. You see? The same car is a set of parts and bolts and nuts and whatever. You see? So, this is pretty much scalar, and if you think of it, already dates are also problematic if you don't understand what is a scalar value. So what is a date? Day, month, year? No, it's still a single date. Because we treat it as a scalar value. So, we immediately solve problem. This doesn't break Boy's code normal form anymore. We still need other constraints. However, it turns out that these other constraints are immediately much simpler once you have this data type. So let me show what I'm talking about. Now please understand, I'm not going to go into details how complex temporal queries with from and to become. I think just to express overlaps, it's already a complex thing. I will just show the solution with this interval data type. So, first this is the code, okay? And of course, in SQL Server we cannot create data types in Transact SQL, so this is .NET code. In this case it is C#, will be also VB. I will just briefly comment this code. I will not discuss in details. You can use books online to read how in details how you write these data types. So first I have, okay, these are just namespaces I'm using. And first I have some attributes which are used by SQL Server Query Optimizer and SQL Server in general to understand about this data type some things. So for example, I say this data type is byte ordered, which means that index on this data type makes sense. Order like it is stored byte by byte. And it's stored in native format. Native format simply means first variable first, then second. So sort in this case of this interval would be based on the begin first. So intervals would be sorts like this. 1, 1, 1, 2, let's say 1, 170, 1 would be before 2, 2. Okay? Because it's byte ordered from left to right. Then, okay, we have two constructors for known and unknown. So if we get known value, we will begin and end interval and put this flag is null false, or the opposite, put the flag is null to true. This is not even interesting. You can put any value here. Now every user-defined data type must have default string representation, must override to string method. Every user-defined data type must implement null handling, because in SQL Server we must support nulls. So these are two methods, two properties to handle nulls. This one is used by SQL Server, and this one is used by .NET Code. You see, if you use this data type in .NET Code, you get byte string from SQL Server, so you must cast it to appropriate data type. And then this is used to check nullability, you know, in .NET Code, like something object dot is null, and the other one is used for is not null operators. This is the other one. So you must implement both of them to properly handle nulls. And then default, this is also prescribed by Microsoft, default method to insert data in user-defined data types is through strings, and then you must implement parse method which actually parses these strings. And of course, I enforce this structure, so I enforce intervals like this, begin, and I didn't decide for brackets, although I have closed intervals because brackets are identifier delimiters, so I don't want to mix this with SQL Server. And of course, I have some validate method, which we'll see in a minute. Up to here is something that every data type must implement. Okay, not every data type must implement this byte ordered, but remember we must support total sorting. So this is then begin, end as properties, so I can separate it, get begin and end, and again I decided for beginning and ending not to interfere with begin and transact SQL keywords. This is validation method. In every input, no matter whether it is through properties or as a full interval, we simply check whether begin is lower or equal than end. And these are these Allen's operators, all of these Allen's operators, including operators of interval algebra, which already use Boolean operators. Okay? Now let's use it. Enable CLR, deploy the assembly, permission set is safe, I'm not going anywhere outside the database, and create data type. So now from this point, it is simple. Before I create table, let me test this data type. And the comment here says this is a good thing. Once you get told to realize that you have to comment everything, otherwise you forget. It says show this in text mode because I want to check many things at the same time. So there's these print messages and selects, which will test all of these operators. So let's see how it works. Testing presentation, this is default. This is toString method, and this is through properties, you see. This default, SQL Server just sends the byte string, so cast is then done by client. This is because of performance. So what if client is not .NET, so cannot use this class? This class must be visible to client either as part of the project or in global assembly cache, right? If the client is not .NET client, client can still use toString method and other methods to work with this type. Okay. It's similar like, with spatial data types which are implemented as CLR types by Microsoft. So you work through methods, and if you really want to work maximally efficiently from your .NET code, you can download the definition of these data types and include project references and then cast on client side. Okay? So this is before, yes, this interval is before that one, but not after. So these are all these operators. This first interval includes the second one, right? And then we have intervals that meet, and then we have intervals that overlap. And this interval begins the other one, testing whether null is working, setting null, and checking is null. Also, setting properties directly through begin end also works. So I can have original interval and then just change begin to 4, end to 5, to 10, it works. Let's see interval algebra operators, how they work with different intervals. So we have this situation. Intervals that meet 2 to 3 and 4 to 8. Union makes sense. Intersect makes no sense. Minus makes sense. This is full first interval. Interval that have nothing in common, even minus, what does exactly mean? Okay. Could also define differently, but this is how Allen defined, so I'm just following this. Could also say, yes, this is still full, this interval, but let's follow this Allen's rules. Intervals that are overlapping, everything makes sense, okay? everything makes sense, and intervals where one is contained into another, union and intersect make sense, while minus doesn't make sense. Okay, let's now create our tables that support full temporal constraints. Now, what I'm doing here is completely the same schema as it was, just instead of since in semi-temporal, I'm using during. However, take a look at this. Beginning and ending are two persisted columns made from properties. This is because I want to create foreign keys on my date-nums table. And unfortunately, SQL Server doesn't allow creation of foreign keys directly from CLR properties. So that's why I need this redundancy. Now, let's find, so this will ensure that begin and end are valid time points. Production suppliers during, great. Now here I don't even need this redundancy, because I will have a different constraint. This during for a specific supplier will have to be included in some during in the suppliers table. And because of the foreign keys to date nums table, that during is already representing valid time points. So this one should also represent valid time points, so they don't even need to make any additional foreign keys and any additional redundancy and persisted columns. So these are these foreign keys beginning and ending to date nums table to ensure that we are dealing with valid times. Now we still have relationship to from suppliers products to suppliers and to products, because we still must have valid product ID and supplier ID. Now take a look at these triggers. Now imagine this huge problem that interval in suppliers products must be included in some of the intervals for the same supplier in the suppliers table. Suddenly becomes extremely simple because I have this data type. How is it possible? Actually, if you would analyze the code, you would see that I actually copied the trigger from the since demo, from the semi-temporal demo. I actually copied it, and I will show you what I modified. This one is after insert and update, so I'm checking completely the same. Checking from inserted, if there is some inserted row for which doesn't exist an interval in the suppliers table which would include my current interval. So the only change is this row from the since problem, you see? Why? Why so simple? Because I included knowledge in my data type. So you see, not a problem at all. And of course, I must also create the second trigger, and here I had to modify two rows. This where condition, okay, but also this. You see, now I have multiple rows for the same supplier, so I can delete some row. If there is no interval in supplier's product, which would be included in the interval of this row. Foreign key will not prevent division, right? Actually, there is no foreign key from suppliers anyway, so it cannot prevent. It's just from. So let me create also this trigger, and you see because of this knowledge I put in the data type, everything else or some constraints are very simple. So let's insert some valid data. Supplier 1 has intervals 2 to 5, and then 7 to 8, and then I have supplier 2 interval 1 to 10. Okay? This is default representation. Now I can go back to text mode, and you see if there is no comment, it's hard to remember to switch back. So supplier's products during for supplier 1, some interval 2 to 5, which is included in this interval, so it's fine. So in this case I have only one valid row. Now let's try some invalid data. Well, this is invalid time point. Okay, this was rejected by foreign keys because and these foreign keys needed persisted properties begin and end interval. Let's try to insert supplies in interval 2 to 6 for supplier 1. Remember, supplier 1 has no interval that would include this interval, was 1 to 5 and then 7 to 10. So this was rejected by the trigger on the supplier's products table. Now let's try to update during of this supplier. Supplier 1, remember, I have during 2 to 5. And I also have supplies in this time point, to this interval 2 to 5. So if I change this interval to 3 to 5, then I would have a product which was supplied before the start of interval where the supplier was under a contract. And let me try to delete this one. I cannot. However, I could delete the other row for the supplier 1. Querying. Well, querying is also very simple. First of all, I need now 2 joins to get begin and end interval, okay, to get the full meaning of from and to. But let's say, what if I want to find all suppliers during this contract, 7 to 11? No problem. Same query, just the where clause uses these data type methods, right? Or suppliers with a contract during an interval that overlaps with this given interval. These were these 2 suppliers. Or suppliers with a contract in a specific time point. What is a specific time point? This is just a unit interval. So again, we just use includes, and then this was a supplier in this time point. Now, immediately to tell, this is great, and code for triggers is typically also performing well, but I have a problem here that could mean performance problem. This is not a searchable argument. So index would simply not be used. So this varies per forum full table scan, so that's why the second presentation is needed. See? In triggers, this is not such a big problem because we are doing for a single supplier. So you may, typically you have 1,000 suppliers and each one has maybe 3 rows, so this is indexing, and then if you scan after you have found 3 rows, this is not a problem because they are on the same page, so no additional reads, so this is efficient. But if you would have a supplier with, I don't know, 100,000 rows, intervals, this would also be a problem. Okay? Anyway, if you think from real life, triggers are not problematic, but queries could become problematic. Queries would mean scan. Okay? Now let me go back to presentation and see constraints. We solved many constraints, but still we haven't solved all possible constraints. So remember, I said I don't want to have something like this. I want, this is supplier under this contract, in this time points and in this. I would prefer to have then a single row from D05 to D07. Okay, I could start thinking I've got overlaps operator. Yes, I got union operator, but still this must be working over rows. These operators work on single interval. Also, I don't want to have these meeting intervals or abutting intervals, right? This should be merged as well, right? And I can test if they meet with meets operator, but again, I must work over rows. And this is not simple. So merges is logical OR of overlaps and meets. This is what we already know from analysts operators. Now think of it. If I would have an option to already store intervals in the most possible compact form, let's say immediately, or some option to do this later, however, then these problems would simply disappear. So what is this minimal forum that still covers all time points? Let's call it packed forum like there is the 840. So, packed forum, not even to go into details, they did really purely mathematical definition, but you can see immediately that the packed forum would be that I have only one row with time point with a single interval from D05 to D07. And also here, only one row with a single interval from D05 to D07. This would be the minimal forum that still covers all of the time points. Okay. Now immediately when we define this kind of minimal forum, we can define also maximal forum, the forum that uses maximal number of rows possible. And let's call this unpacked forum, and let's call the operator that gets us there unpack operator. So what would be the unpacked forum? Well, again, they did purely mathematical definition, but what we can think of it and see immediately logically what would be the forum that uses the maximal possible rows to still cover these time points, exactly the same time points, would be the forum where every single interval is a unit interval. So I would have three rows. I would have three rows. D05 to D05, D06 to D06, and D07 to D07. So this would be the maximal forum, unpacked forum, that covers all time points from 5 to 7. Where all intervals are unit intervals. And in every row I have a single unit interval. Now, also I want to prevent this kind of contradiction. Remember, I want to have one supplier under a single contract at one time point. And please understand that this is a constraint that might pertain to your business or not. Just trying to solve also this problem, if you have such a constraint. Well, let's look at this. Let's create unpack forum from these two intervals. So I have supplier, contract, and unit interval. Now, please take a look on these two columns, supplier ID and unit interval. If I could somehow make this unique, I could have them in a single time point, only a single contract. So if I would be able to make some kind of key over supplier ID enduring in the unpacked forum, this would prevent contradiction. And packed forum would prevent overlapping intervals for the same contract and meeting intervals. Okay? So what I need is pack and unpack operators. Now, don't want to show the next slide yet. Also, you see, when you are packing the luggage, right? Doesn't matter what is initial state when you decided to pack. If you do it properly, the final state is packed. Either, no matter if initially it was half packed or fully unpacked. Okay? And the opposite is true as well. When you unpack your luggage, it doesn't matter what was the starting point. Okay? When you finish, it is unpacked. So, it means, this is written on the next slide, but I don't want to show the next slide yet, I said. So it means that pack of a relation is the same thing as pack of the unpacked relation. And the opposite also. Unpack of a relation is the same thing as unpack of packed relation. Okay? No matter where we start, we finish at the same point. So, for example, instead of trying to find a solution how to pack initial intervals, I can try to find a solution how to pack unpacked forum. But how do I get unpacked forum? Well, think of it. What I need is, I need to generate rows for all time points. So how do you generate rows? Let's say that you need to generate a row for multiple rows for a customer, one row for each order. How do you do this? Join. Simply, yes. Simple join. Now where I'm pointing to is, of course, we don't have pack and unpack operators, but we know that we can express them with other operators. So apparently unpack will be somehow connected to join. Now what do you think? Which operator will be used for packing? Now from multiple rows I must get single row. So I must find a way how to implement this with group by. So to which table I should join my intervals table to get unpacked form? Where do I have all of the rows that I need? In my lookup table. You see? Now suddenly everything makes a lot of sense. Because I implemented these intervals with integers, not with dates. I got many additional things. I got full support for begin end times I defined. So I can define minimal and maximal possible time. So I'm sure that all intervals are due in this time. I can also unpack it. I know I'm supporting total ordering. And also I'm supporting minimal storage. Also quite efficient. Yes, I lost something. I need joins for queries. This is true. I need joins to get the context. So let's now see how this can be implemented, and note that of course we still must implement then pack. Now you see, preventing overlapping with a trigger is not simple. So let me start explaining this situation. Now imagine that I would create, and I will not even try to use this, I will just drop it later. So imagine that I would create a trigger like this, kind of name solution. Okay? I don't allow to insert anything where an interval is mergeable with some other interval for this supplier. Do you see any problem with this trigger? Well, my tables has become read-only. You know, this is after trigger. So this will always give the result for the row that was just inserted. This row already exists in the suppliers table, so it would already be joined with the inserted. So this simply means I cannot insert any row in my table anymore. No, doesn't work this way. If you want to have updatable data, there are also other solutions. You could simply create a column store index and also get efficiently read-only table if you really reach this, and you would also have faster query. So it doesn't make sense to have this trigger. Then of course the next thought is, why not using instead of trigger? Well, I will just show the code. And you see, code becomes immediately extremely complex. So this is our suppliers, right? Instead of insert and update. So first, I decided to even show this code in a reasonable way. I will disallow anything but single row updates. Otherwise, you have to think of these problems. And then disallowing update of delete of supplier ID. Otherwise, we would have to deal with these problems as well. And then you can check for meeting and overlapping intervals, and then you can roll back transaction. But if transaction is not rolled back, remember that instead of trigger intercepts the command, so you have to repeat it. So if everything is alright, let's repeat the command. And suddenly, although I have interval data type, this is not so simple trigger anymore. Some triggers were simple, but this one is not. Whoops. Nice. Oh, we are getting, no, we still have time. Insert doesn't work. So insert invalid, okay. Valid insert would work. So trigger somehow works, but I have only single row updates, right? And I prevented updates of supplier ID, which is not a good practice anyway, but now it's explicitly prevented. And I also prevent deletes. No, this is delete, value delete if this is not included. Now, if this interval doesn't include any interval in the supplier's products table. Now let me show you how this can be simplified with pack and unpack operator. First, I must create auxiliary table, otherwise when I will create constraint, that will prevent overlapping and meeting intervals in unpacked forum, I will not be able to insert this data for first supplier. So how do I get this? So this is temporary table just to show how to get unpacked forum. They're very simple. I'm joining this table to my date numbers, where number is between begin and end interval. That's it. And I get enough rows, so I can create from this time point unit intervals. So this is kind of initial interval, okay, this is unit interval, and this is time point. So I got unpacked forum, and now in this unpacked forum, of course, I have these points which repeat. So I cannot create uniqueness on this yet. That's why I actually needed this additional table. Now let's go back to the source table. And how do I create this kind of, let's say, unique or primary key constraint on this table when it is not unpacked? Well, I can create a view that it's unpacked, and then I can index that view. So let me do this. Create a view with schema binding and create unique cluster at index. Now let's try, let's see what I've got currently in the table. So I have supplier 1, which is in time points 2 to 5. And this overlap with time points 1 to 3. And you see, this was simply rejected by my unique index on my index view. So I cannot insert overlapping or meeting intervals anymore. Now packing. So let me try to pack. So I need something that will identify my intervals that can be grouped. Rows that can be grouped and intervals packed. Okay? So let me just show you this. Okay? Start it with unpacked forum. Okay? And then let me show you this second. So I have unpacked forum, and in this unpacked forum, I'm adding dense rank, and this is time point 10, okay? And dense rank over time points, so dense rank for the first time point is 1. For the second time point, no matter from which interval comes, dense rank, please note that I'm working on this table, that temporary table again, that can't be packed, okay? Initial table is already packed. Dense rank for the second time point is the same. And for the third time point, dense rank is the same. Yes? But then I have a hole. You see, dense rank for the seventh, this time point is 6. Right? And then I have a hole. So I have 3 time points missing. Okay? 2 time points, 8 and 9 are missing. So the difference between 7 and 10 is 3. However, dense rank maintains difference 1. Okay? Now look at this simple mathematics. If I subtract dense rank from my time point number, you see, for all of these time points that are in a sequence, I always subtract something that is exactly 1 less. So I always get result 1. And then I get different result because this is difference 3 while here is difference only 1. However, for the next time points that are in sequence, I still get the same result. So this is actually the formula, this is my grouping factor. This actually tells me what I can use to group intervals. So now I can define packed forum or pack operator by just grouping over supplier ID and grouping factor, and then just create these intervals from these time points. So this is now the packed forum for my table. And efficiently we got packed operator. Now you can see that we are coming close to the end, and yes, it is a good practice to execute this, otherwise next time you get surprises. So now we actually solved all of the problems. Now let's just briefly discuss the 6 normal forum, how to maintain the history. And actually, because of, let's say, time limitations, I skipped this in presentation, but in the chapter, in the book, this is in details with all of the code as well. So there is another piece of code pretty long. So this is, for example, this table. So actually what we need for total auditing and all versioning, we need kind of a separate historical table for every changing attribute. For every changing. So if company name changes, we simply insert row here and say it was valid from that point to that point. And here, you see, we can even have, in this case, we know that this is now not contract, this is base table, so we have this is valid since. This is simply valid since. And this one is during. And this is the one, let's say, with contracts which are closed. This is initial, so this data for this supplier is valid from this time point. And here is the history for names, and then you would need the history for other columns. So this way you would get total history for any column that needs to be maintained like this. Okay? Of course, you can imagine that this leads to a lot of additional tables. Most of the time, systems solve this differently, by simply storing the transactions, and then it's up to you how to regenerate this. This is the forum that enables you to query immediately, state in any point in history. Any point. This normal forum was proposed by Chris Date. However, this forum is slightly different than his proposition. This, I have only one since here, which is since for the complete row. This is the latest data. Chris Date suggested that we should have since for every column. And I think this is not correct, because first of all, I can get for every column from the history table, any state. Okay, can get since when it was and so on valid, and because I see when the last previous state ended, so I can always get the since. So having since for every column. So he suggested we should have company name since, and then we should have address since. Said no, we need only one since for the full row. Because this would be redundant, because I can always get this data here. And also then, let's say company name since would actually break the normal forum. It wouldn't be dependent on the key only. It would be dependent on key plus this column, plus company name. So this model is even simplified, and I think it is slightly more correct. Okay, questions?
Your data type that you created, is it created in the database or the instance?
Database. You always create data types on a database level. There are no instance level data types, like even if you create them in master, they are not visible in other databases.
So you restore there.
Yes. So you must create it in any database you want to use it. Oh, yes, I didn't mention it. I mentioned one problem. There is another problem in this solution. Did anybody notice what other problem I introduced? Think of unpacked forum. This might be also a performance problem. You see, now imagine that I have contracts that are, let's say, in average valid for 2 years, and my granularity is date. So from one row, I efficiently created 730 rows. So see, I introduced another problem. Okay. So in next model, I hope we will meet in the next model I'm talking about. Like this is a training in next, what is it called, presentation session. I will show you how you can solve these problems, optimize these queries that deal with huge amounts of data. Triggers probably don't need to be optimized, they are fine as well. And even how to find a more compact, unpacked form. Any other question? I have some takeaways from the beginning of conference, and I told you I'm getting old, so I always forget on every session to mention them. So then I decided, always remember after the session when people were out. So I decided before I say thank you, I have to, this is a reminder for me. So what I've got here, I'm also writing courses for Pluralsight, so I have free one month unlimited pass for all Pluralsight courses. And I have these mini cards with discount code for the 2 latest books I co-authored, the training kit 7461, Training Microsoft SQL Server 2012, and the training kit 7463, Implementing a Data Warehouse with Microsoft SQL Server 2012. And just to let you know, these books are valid for 2014 as well. There is nothing new in these areas in 2014, and also the exams will not be upgraded. So please feel free to take anyone. And note that if I have only few for 7463, but to take this one, the code is the same because code is bound to author. So you can use the same code for even if you don't get both of these mini cards. So thank you very much for attending this session, and hope we'll see you on the next session. Proposed relational interval trees, a model that can help optimizing these queries. However, turns out that this was purely theoretical solution because, yes, if you got these relational interval trees, then you can speed up queries. However, building these trees was too expensive. And in 2011 and 2012, Laurent Martin from France invented mathematics needed to build relational intervals trees with simple calculations in linear time. So this suddenly became kind of possible. Now let's go to practical solutions. So I first implemented full solution for temporal problems, including constraints, the part that this talk is based on in this book, Inside SQL Server 2008, Transact SQL Programming. And I'm co-author, my author is Itzik Bengal. And last year he published interval queries in SQL Server article where he introduced Transact SQL solution for relational interval trees. There is a slight deviation. Davide Valauri, guy from Italy, also last year published possibility to use spatial data. And I added last year 3 additional solutions for optimization of temporal queries. And in the end, I will also, in the end of the next talk, I will also introduce the 4th one, which I am currently working on. So you will see that after all of these years, we have enough solutions. Together we have 6 different solutions, 5 of them supported with the code. The last one I will talk theoretically, it's only an idea so far. Let's say not just idea, it's already an algorithm. Just somebody needs to sit down by the computer and start programming. And so we have different ways how to optimize, and we can implement all kinds of constraints. And yes, I still think that it would be at least partially duty of Microsoft to put more support in the product, and also other systems like Oracle and DevWeek should put more effort. But at least, let's say, it is finally, let's say, doable to get a reasonable solution that supports everything you need from constraints and also gives you the performance you need. So, what are actually temporal databases? You see, in a relational database, in a relation or in a table, every row or tuple actually represents one proposition. So if you look at row of a customer's table, you see the proposition customer with this name lives on the doors, pack and unpack, and briefly discuss the proposed 6 normal forums. And in the second part, the last talk in this today, I'm going to, of course, talk about optimization of temporal queries, which is also very specific and, as you will see, pretty much completely new. So, theoretical background. James Allen already defined what kind of operations should interval data type support in early 80s. So this is the point when the theory started to evolve. And Chris Date and Hugh Darwin and Nikos Lourenzos wrote this book, Temporal Data and Relational Databases, at the end of previous millennium. It was published in the beginning of this millennium. So this is kind of strong theoretical background for the complete temporal data support, not just the data type. Also, you see, problems with optimization evolved immediately. As soon as you introduce temporal data, you have some problems. However, until 2000, there was really no theory behind how to solve these problems. So in 2000, Kriegel, Petke, and Ziegel from Munich University published this white paper, Proceedings from Conference, where they... I guess we can slowly start. So, good afternoon. Welcome to the first afternoon session. I'm going to talk in this and in the next session about temporal data. So temporal data in relational database in SQL Server, which is a topic that, although frequently people have problem with this kind of data, it's not really well covered, and definitely we are lacking support for this kind of data out of the database. My name is Dejan Sarka. I think we all met already, so I will not spend a lot of time here. So in this first part, I'm going to define things. So what exactly is a temporal database, and focus on constraints. So what kind of constraints can you have? I'm not saying that you must have all of them, depends on your business program. But what kind of constraints do pertain to temporal databases? And then I will show possible solutions and kind of simplify the problem by introducing a new interval data type. And then we will still have some problems left. So some constraints to develop. So I will also develop 2 new operate at address and if his company has so many employees, etc. So this is proposition or true fact. Now, these kind of propositions are simple, are not time-stamped. So we pretend that these kind of propositions are true forever. So they have been true forever, and they will be true forever, and they are true in this moment. Temporal database is called time-stamped propositions. So propositions that are valid, true, only in a specific period of time, in validity time. And these intervals can be open-ended or closed. So we can have open-ended or semi-temporal propositions, like this proposition is true from or since some point in time. Of course, we could have open on the other side as well, so we could pretend that some proposition was true forever, but is true only until some point in time. Anyway, to solve the problems, we need to focus only on one side, so I will deal only with since propositions, not until or up to some point in time. And then we have propositions that are valid in a closed interval of time. So from to, or with a single word, they are valid during some interval of time. And we have many business problems which such